Okay. Yesterday we were talking about, these various cases of solving inequalities. Okay, we even mentioned quadratic formula, and we did the example. We did a number 12, right? And two different methods. Well, two different methods using quadratic equation and so on and so forth. But anyway, we have covered all of these variety of methods, okay, and using variety of tools, okay. And today, I think we will be able to work on some other questions. Some other questions. I don't think we need to be here for very long, and it seems you guys have these ideas about using quadratic formula, completing a square, or factoring in combination with quadratic 4. I think we should be able to handle these very well. Anyway, let's do one or two more. Just make sure that we can handle some other cases, such as, if the parabola opens down. Okay. Do you guys have any questions? Have you guys tried the rest of it in basic 9? Or you find it okay? Yeah? No? No questions? Okay. Take an example of number 19. Okay, so let's look at number 19. Oh, sorry, 17. 17. Okay, we have a negative x squared minus 2x plus 3 less than or equal to 0. There are a variety of ways to handle this. Okay, there are a variety of ways to handle this. And of course, you can see the first question you might be asking, could I factor this, right? Could I factor this? If we cannot factor, we just treat it as a quadratic function, and we want the quadratic function to be less than 0 or equal to 0, right? So there are so many ways you can do it. But one of the simplest way to do it for me is that I would just multiply both sides by -1. So that way I will get x squared plus 2x minus 3, because I multiply both sides by -1, so this becomes greater than or equal to 0. And then, of course, you know what to do the rest for the rest of the solving these inequalities. Yes? Right? So far, so good? So in fact, all the quadratic equations that opens down can be converted to opens up this way. So you'll be able to handle it with the normal method. We solve quadratic function. We handle quadratic function when it's opening up. Okay. All right. So can you guys finish this? Could you guys complete solving these inequalities? Any which way you want. Any which way you want. when you actually handle this inequality, you will be in a situation of, this will probably part of an inequality, a part of a bigger question. So you want to use the simplest way you can think of to solve this inequality, right? So can you finish this, solving this inequality? Okay, so let me put a little note here. Multiplied by -1 on both sides of the inequality. I can put this over here. Multiply by -1 on both sides of the inequality. And then we will, get this. And from here, okay, I assume you guys have almost done. So this is going to be x plus 1 multiply x plus 3, x minus 1. Okay. It doesn't matter which order you put it here. I'm just going to put it in this order. Right. And by this time you vision this is a parabola. This is a parabola. This parabola opens up. Okay, the original one opens down, right? But it's asking for less than or equal to 0, opens up greater than or equal to 0. So any whichever way you do, right? So you can go graphing. Okay, graphing this parabola. Okay, and you identify immediately these 2 points of intersection, right? Which are the 2 points of intersection, which is -3, 0. And you want to identify that and show it on your graph if you do use graph. Okay. And make some adjustment to your picture. This is 3. Oops. It's a little bit off balance. So this I'm going to put 5. Okay, so this is better. And we want this to be greater than or equal to 0. Then obviously, what you want to mark these 2 points though. If you show work by graph, okay. You want to be able to, mark those points. Okay. You want to mark those points. It doesn't matter what color, really. Okay. It doesn't really matter what color. And at the other point, you just mark this point. You want your reader to understand what you're trying to do. Okay, and your thought process, and it has to be logical. Okay, it has to be logical. And so you show a piece of nice work and then you get all the points. So by this time, and you may also like to mark something like, this piece is a positive, this piece is a positive, this piece is a negative, right? To show the picture. Because and then then you will say the solution. In that context, the solution would be x less than or equal to -3 or x is larger than or equal to +1. Then you're done, okay? So don't hesitate to use the principles, number 1, 2, 3, 4, 5, 6, whichever one, is applicable to serve your work, okay, to serve your purpose. Because sometimes you can make your life a little bit easier, okay? Typical example number 16 is similar, so we're not gonna do that. One more. Did you guys try any other method you want me to go over? This question is similar to what we did in quadratic 4, so I don't anticipate any question, but if you do, don't hesitate, okay? In quadratic 4, we solved it with completing a square, didn't we? We solved it with completing a square. So here we use slightly different methods. So you can see all of these methods is at our disposal. Okay, you will never be able to run out of method. You'll be able to, because you have all these connections in your head, right? So you have freedom, you have, but you do need to enhance your algebraic skill though. Okay, we do need to enhance our algebraic skill though. Okay. I think at this point we can move forward. Okay, we can move forward to quadratic. Let's see. So we do quadratic 5. I personally really think you guys can handle quadratic 5 pretty well yourself, because there are a series of questions and I put there, and we did a quadratic 4. For the quadratic, I have so many questions put it in the notes. And I assume you guys can handle them yourself, yes? Okay, so we did a quadratic 4. Quadratic 4 is here, right? And let me show you the screen. You know what I'm talking about, right? Okay, so let's have a new share. Okay, this was a quadratic 4. We did a quadratic 4 from the beginning to end, right? Quadratic 5 is similar. Quadratic 5 is similar. So I'm not going to do it in class. You should try them. And quadratic 6 is an example that parabola opens down. Okay, everything is similar. Vertical cut, horizontal cut, and so on and so forth. And quadratic 7 is opening down again. And from quadratic 4 to quadratic 7, these examples are parabolas open up, open down, but touch the x-axis twice. And from quadratic 8, the quadratic opens up, but touch the x-axis once. Okay, and number 9, it touching once. So this is another kind of example. 10, quadratic 10, no touch. So we have all 3 cases covered in these examples. Okay, completely opening down without touch of the x-axis. So all of these cases are covered for you. So if you go through these processes, okay, do every one of them, you should be very, very good at quadratic by that time. Okay, but we don't have time to do each one of them, 20, 24 questions, 26 questions. We don't have that kind of time. Later on, okay, the question that was given to you, like quadratic 13, there's no curve. right? So you have to put the curve in the spot. You have to put the curve in spot. And I'm going to assign these as your homework. And then for quadratic 16, I have all these, different kind of questions given to you for your practice, And of course, we don't have time to do them in class. Okay, we don't have to do them in class. But if you have any question, I will be more than happy to make time for you, okay? So these are going to be your homework, and I really want you guys to work on it because I have all cases covered, all cases about quadratic covered. And why these kind of questions are so important? Because quadratic tends to be that perfect academic questions that you're always going to encounter, no matter what classes you take in math. Even you will see this in business. If you're a business major, you're going to see this in business because some of the business models, they're quadratic. Okay. These quadratic is a perfect question for academics. The other reason is we know everything about it. We know everything about quadratic. Okay. So this is also one of the simple polynomials to work with, and there are all kinds of things that questions can be asked about it. But if you just go through all of these questions I have given you, then you will be invincible. You'll be invincible because I pretty much have covered every aspect of these quadratic. Okay, and if you need more reading, you can read my my brief summary on everything quadratic in the module. And then if that's not enough, okay, the writing I put there was not very complicated. Okay. And there's not a lot of redundancy. Okay. So if you need more reading material, just grab your just grab any intermediate algebra textbook. Okay. It should have a nice coverage. It should have a nice coverage. So next, we're gonna go to basic 10. Okay, we're gonna go to basic 10. So we're gonna stop share on this one. And so look at basic 10, everybody. Okay. And I'm going to bring you back to my other screen. So let's get started on basic 10. Basic 10. Basic 10 is solving inequalities again. I used to mix basic 9 and basic 10 in a topic called basic 10A. And this semester, when I was working on the notes, I separated them. And then later I forgot. So that's why I refer to basic 10A. But this semester I separated them. Okay, so basic 10 is another kind of inequality, which is you see quotient, right? You see quotient. But really, there's not much of a difference at all. Not much of a difference at all. Okay, so let's look at a first simpler example. Okay, basic 10, number 1. Okay. Suppose I have x minus 3 over x plus 1 and greater than or equal to 0. Okay, of course, what does it mean? The sentence is an if statement, right? So this is an if statement. Excuse me. If x minus 3 plus over x plus 1 is greater than or equal to 0, right? And then we're gonna find all possible values for x, right? So that it is true. Okay. And before I before I work this out, and I also want to give you the perspective of function perspective. Okay, of course, this time this rule is not a quadratic. This rule is still a function. So this x is as input, and this is the output, right? So this is the rule to produce an output, and we want the output to be what? To be positive. Wait, there I go. To be positive or 0. Okay, so that's the scenario. So in terms of the sentence, the structure of sentences, and in terms of the meanings of functions, there's no difference. You can see that it's just a quadratic. You could have a quadratic rule. It's sine, you have sine rule, and cosine, you have cosine rule, and so on and so forth. Okay, and it each comes with domain and range considerations and so on and so forth. Okay, and this time we want the quotient to be positive or 0, right? Greater than or equal to 0. So next, I want to give you a couple minutes. Okay, how would you work this question out? Okay, everybody put on your thinking cap. Please, everyone, try this. Okay, you can take a picture and send it to me, and you can also upload. Okay, let's see what's on chat. There's one message on chat. Very good point, Cortland. But you said x cannot equals to 1. Well, you're close. X cannot equals to 1, -1. That's right. X cannot equals to -1. So we're gonna have a discussion as how to approach this. Okay, or we call it think out aloud. Okay, so one of the points we make is that x cannot equals to -1. That's a very good point. Yes, we must make sure, okay, from the function's perspective, denominator cannot be 0. This is a rule, okay, even though I didn't make a, even though I didn't, make a f of x equals to so on and so forth, it is a function, it's a rule, right? It is still a rule. The rule produces something like this, and then we want it to be positive or 0. Okay, very good. That's a very good point. And then how do you solve it? How do you solve it? Anybody want to show your work? Any method is welcome. Okay. Anybody? Any contribution? Okay. How's it going? What did you get? Okay, Corin says x is less than -1 or x is greater than or equal to 3. Okay, so one solution we have here, okay, I call it A. X is less than -1 or x is greater than or equal to 3. And Mikhail get the same answer. How did you guys get it? Do we have any other answers that you want to share? Okay, multiply both sides by x plus 1. Okay, so let's see the house. Okay, let's see the house. Okay. Multiply both sides. Multiply both sides by x plus 1. So this inequality, multiply both sides by x plus 1 with multiply by x plus 1. And what do you do with the inequality sign? Stay the same? Do you, when you do the multiplication, do you stay the same?
It should stay the same.
Okay, it should stay the same. All right, so and then what you do? Are you crossing out the x plus 1? And then what? What's the next step? Do you get x minus 3 larger than or equal to 0? Is that what you're getting? Yeah? And then you get x larger than or equals to 3. That explains your solution of x less than greater than equals to 3, but doesn't explain how you get x less than -1. How come x less than -1?
Well, I had thought since that it can't be -1, or else if it was -1, it would be undefined.
Right.
That everything else behind it would be the correct answer.
Well, just because it cannot be less than cannot be -1, it has to be less than -1. So what reason do you have to justify it has to be less than -1? Sure, it should not be equals to -1 for sure. This point you guys made is absolutely correct. But just because it cannot be -1, it doesn't mean it must be less than -1. So, or it could be greater than -1, right? So how do you choose between greater than -1 or less than -1? You understand my question?
Mhm.
So what is the justification?
Well, you could put that on a number line and you could see the signs.
How do you put the number line and see the signs? So can you construct that? Could you show me how you do that kind of number line?
So you would put like -1 on a number line, and that would be undefined. And then for the values of -2 and -3, that would be, what do you think it would be? Hold on.
Is that what you're talking about?
Yes.
And then
I mean, you would just find the signs for each of those values.
you find the sign for each one of the interval.
Yes.
That's very good. That's very good. However, okay, this, okay, looking at this number line, I wish you can give us some more details about this part. However, this piece of work is completely wrong. Okay. You guys might be shocked because this is what I'm waiting for. This is one of those very common mistakes we see from our student of all times. Okay. All right. I still haven't tell you if your answer is right or wrong. Okay. Just wait a little bit. Okay. why is this piece of work wrong? I want you guys to write this down. Okay, put it in your notes. This is very, very common mistake. Okay, very, very common mistake. And there's a reason why this is a mistake. Okay, we do the sine of x plus 1 is unknown. That's the reason. Because when you multiply x plus 1 on both sides, in the case of inequality, if the sign of x plus 1 is positive, where x is greater than -1, sure, we're not going to make x equals to -1. X, you guys get that part right. X plus 1 cannot be 0, so x cannot be -1. That's for sure. We guarantee all of that. Even if you guarantee all of that, excuse me, even if you guarantee all of that, you still don't know what the sign of x plus 1, right? So x plus 1 could be positive. If x plus 1 is positive, when you multiply on both sides, your inequality sign will stay the same. But if x plus 1 is negative, you have to switch the direction of inequality sign. So when you multiply x plus 1 on both sides, just like this, without indicating x plus 1 should be positive or negative, and this kind of step, so this step from here, this step, oh, sorry, erase that. Okay, so this step is a fatal mistake. Okay, fatal mistake due to what? Due to that the sign of x plus 1 is unspecified. It's unspecified. Then you say, I cannot specify. Yes, if you cannot specify, you should not do it. Do you follow me? You simply cannot do it. There's no such mathematical principle to support you. Okay? There's no such mathematical principle to support you. You guys got follow me? Because if you multiply both sides by positive, you don't switch the direction. If you multiply by negative, you have to switch the direction. So you're facing the dilemma, do I switch? Do I not switch? Because you don't know the sign of the multiplier. You don't know the sign of multiplier. Unknown, completely unknown. We don't know the sign. Okay, so that's where the mistake is. I want you guys to write this down and never ever make this mistake with inequality. Okay, so here I have the reason written down for you. Of course, because this step is unjustified, the rest of the work is is null, is invalidated. Got it? But I do want to continue the discussion of Mikhail just indicated. We do need to work this interval. We have 3 intervals to work with. We have 3 intervals to work with, okay? So in that regard, and I think you guys have a, I first pointed out this is a common mistake, and next I'm going to show you how to show work, okay? The way you do it by picking up 10 points on each interval, that works too. That works too. But I'm going to give you a little more details about this. So did you guys write it down? Did you write it down? Okay. So I'm going to clean up everything. Okay. So let me indicate common mistake. Okay, that's a common mistake. So this here and common mistake. Okay, so here that's a common mistake. Okay, the next one, which you consider the sign on each interval, that is correct. That is correct. Okay, so I'm going to elaborate on this one. I'm going to elaborate on it. I'm going to take this interval. Okay, so I'm just going to go straight to the solution. Okay, I'm just going to go straight to the solution. Because we want this quotient to be greater than 0 or negative or equal to 0, right? Before I show you the solution, I want to give you another perspective. Okay, this perspective is we view this quotient as two numbers. Remember we talked about this when we were doing number 1 on basic 9, right? You see this as a quotient of two numbers, right? When does the quotient of two numbers is a positive? When is that happening? Either A is positive, B is positive, or A is negative, B is negative. From when both numbers are of the same signs, the quotient is going to be positive, right? Principle number 6. That's principle number 6, isn't it? So that should be our guiding, guiding principles. So I'm going to show you the solution. Okay, so we're going to look at the sign of x plus 1. So this comes to, you might have done it differently. Okay, you might have done it differently. So I'm going to put this over here. Okay, so we're going to look at the sign of x plus 1. So what I'm just going to do just more of a step-by-step wise. Okay, so at -1, so you're going to see where the quotient changes sign, right? By looking at each individual factor. So I first look at x plus 1. X plus 1 changes sign where? At a -1, right? So to the left of -1, when x is less than -1, so this is going to be negative. At -1 is 0, right? Larger than -1 is a positive. Okay, so does this look familiar? We actually use very basic, we use principle number 6 in a very basic way. Okay, then you look at sign of x minus 3. Then of course we know that x minus 3 changes sign where? Where does it change sign? At a positive 3, right? It changes sign at positive 3. And how is the sign distributed? Well, when x is less than 3, it's negative, right? At 3 is 0. Larger than 3 is positive. You know that, you guys know the drill, right? You guys should know the drill by this time. Yes? And finally, we look at the sign of what? We look at the sign of this quotient. Remove the greater than equal because you look at the sign in general. Okay, so here I'm going to use this, number line we just adopted. We just worked out, right? So these number lines, and so when x is less than -1, when x is less than -1, we're doing a negative divided by positive. Negative divided by positive is what? Positive. What happened at a -1? We're dividing by 0. Dividing by 0 is undefined. Therefore, I'm going to put a, you can put an infinity sign there. Okay, it's infinity. Undefined. Okay, between -1 and 3. So this is what the Mikhail said. You finally came to this one, you have a negative divided by positive. When you pick a number from here, you plug in this quotient, you're dealing with a negative divided by positive. So that's going to be negative. At 3, what happened at 3? You have a 0 divided by a non-zero number, and that is a 0. And larger than 3, you get positive. Is this what you meant, Mikael? I imagine this is similar to what you're talking about, right? That was me talking about the number line. Oh, sorry, Cortland. I have a hard time telling you guys apart. Okay, my bad. Okay, is this what you mean, Cortland? Yes.
That's what I meant. That's what I
Yeah.
meant.
So you just have to make it. You can just have to make it some kind of. You just have to use the mathematical principle to reason your steps through. Do you follow me? So then as we get to this point, what is the solution? The solution is obvious, right? What is the solution? Of course, the solution, we want this is wanted. We want the quotient to be positive or 0, right? So, and this one, of course, give you x is less than -1, right? And the other piece is x is larger than or equal to +3. Okay, so let's go back to your yeah, the answer is correct. Yay! You guys see that? Okay, it's really a simple perspective. From that simple perspective that we consider this is a quotient, and this quotient, we want this quotient to be positive or 0. Do you guys follow me? You got it? Okay, so this is the simplest case scenario. This is the simplest case scenario. And I want you guys to look at number 2. What would you do with number 2? Okay. What would you do with number 2? Right? Knowing what to do for number 1, what would you do with number 2? Okay, of course, solve for x. Right? We also have that perspective, right? Similar perspective. Okay, except the function, the rule has changed a little bit. Right, this is greater than equals to 1. And if you look at the perspective, you're gonna say, oh, this is gonna be that, and we want it to be greater than equals to 1. We want it to be greater than equals to 1. Right? So all the perspectives are all there, similar. The question is, how do we deal with it? Can you multiply both sides by 3 minus x? Which is very tempting, isn't it? Which is very tempting. The answer is absolutely not. That's another common mistake. Okay, similar to the ones we just did. Okay, I'm kind of moving forward because I already gave you the reason. I already give you the reason for the previous one. You cannot multiply both sides by x plus 1. Has nothing to do what's on each side. So the basic problem is that you don't know the sign of the denominator. surely you must require that x cannot be equals to 3. That's no problem. I can make you happy with that. But even if with x cannot equals to 3, you still cannot multiply both sides by 3 minus x. Do you guys follow me? So this is a common mistake still. Okay, because in this case, it's even more tempting. It's even more tempting to multiply both sides by 3 minus x. Do you guys agree with me? Very tempting. Look at that. If I multiply both sides by 3 minus x, voila. Everything becomes so much simpler. Right? Everything becomes so much simpler, and then I'm almost home. And this is a fatal mistake. By saying fatal mistake, I'm telling you that it's not going to get you a single point. You lose all the points for it. Do you guys get it? For the same reason. Why? Why is that mistake? Right? The sine of 3 minus x is unknown. Okay, or unspecified. Unspecified. Then you say, well, if I specify, could I do it? Yes. But I'm not going to show you the other method. I'm going to show you the commonly used method. Okay, if you guys want to get into that discussion, so what if I specify it? And could I do that? And the answer is yes. There are many methods to solve this inequality. The method I give you is not only one. But I'm going to show you the most common method. Okay, I'm going to show you the most common method. So please don't do this. So end of common mistake. Okay, so this piece is a terrible, terrible mistake. Please, please don't do that. I emphasize it here very, very, sternly, because I see this being done by some of my colleagues. Okay. And I saw this being done by some TAs in the Math Resource Center. So that's even more alarming. So you guys have to, equip yourself with the knowledge to identify the mistakes, even from your TAs, or even from your, maybe from your future professors. Okay, this is not a small matter. But in mathematics, what is interesting is that you like to know that if it is a mistake, it is a mistake always. Do you follow me? If it's a mistake, it is a mistake always. It doesn't matter this person is a professor, or this person is it's PhD, or this person is just a student like you. And you could be just correct as well. Just because you are a student, you could be totally correct. But just because I'm a professor doesn't mean I'm always right. Do you follow me? That you have to firmly stand on your ground, that you need to convince me you're right, and you need to convince me I'm wrong. You need to have that kind of spirit. You follow me? Okay. And I think you will acquire that. And okay, so that's what I emphasize, this mistake. This mistake is so terrible, but it's so commonly seen. Horrible, horrible. Okay. But anyway, there's one semester I was teaching a class. I was teaching a pre-calculus class, and I was hospitalized that semester, and someone was substitute for me. And that substitute teacher, he was teaching this stuff and he taught exactly this method, the wrong method to my student. And I came back and shocked and I have to do it all over again. So I'm not just telling you something that I didn't experience myself. Do you follow me? So someone could be just not being very careful. Anyway, without further ado, so what shall we do? What shall we do in this case? Okay, so now, did you write it? Did you guys write this down? I want you to write it down because this is such a terrible mistake and it's so commonly seen. Okay. I wish to eradicate this kind of mistake. I wish to eradicate it. Okay, so solution. Okay, solution. The first step in the common method is to make 0. Make 0. By this time, you guys probably understand why we make 0, because comparing with 0 is much easier. Why didn't we have to make 0 in the first question? Because it was already made for us, right? It was already made for us. So we make 0. And the second one, we make quotient. The second part, we make a quotient. Because this is no longer one quotient. This is a quotient minus a number. So this is not a ones quotient. So we make a quotient. Why do we make a quotient? We make a quotient so that we can use principle number 6. Do you follow me? We make that quotient so we can make principle number 6. Do you guys still remember what's principle number 6? What is principle number 6?
It's when like the same sign is multiplied or divided.
That's right. It's about the product of the two numbers. You multiply with them the same sign, we divide them by the same sign, different sign, and so on and so forth, right? Quotient, like negative divide by negative is positive. Positive divide by negative is a negative, so on and so forth. But when we don't have a single quotient, we cannot use that principle, right? So we're going to make this one. You can see that it's the principle is guiding our steps. I'm making this claim. I want you to see that from the principle's perspective, everything seemed to be so much simpler, isn't it? That's what I want you to see. That's what I want you to see. So we're going to make that quotient. Of course, making this quotient takes some algebraic steps. Okay, so this is the part I want you to work with me. Okay, so 3 minus x, 3 minus x. So we're making quotient. And next, we basically made the same denominator, didn't we? And then we use the same denominator, which is 3 minus x. And the top is this numerator subtracting the other numerator. You need to be very careful here. I have students in the past, I tell you, this question is one of those questions I test and quizzed many, many times in the past. And the steps I'm showing you, I have seen so many people messed up here, which demonstrated that these students, either they're not being careful, either they're not being careful or they're algebraically very weak. Okay, if you're algebraically not very sophisticated yet, you want to be very careful. So we're going to distribute this negative sign to inside the parentheses. So this is going to be plus 2x, plus x. A lot of students stumbles on these steps. Okay, I have given this exactly the same question to my classes in the past many times as a quiz question or as an exam question. I have seen students stumbles on these steps to make one single quotient. Okay, that demonstrates that's the elementary algebra. You know, that needs to be, you know, to be strengthened in elementary algebra. So in the end, we have this. Okay, so make zero, make a quotient, right? So we understand that when you do this, you understand why I do this, right? You need to understand why you're doing this. You're not just saying the why to your professor, you're doing this why for yourself. Okay, because only after you can convince yourself, you may possibly convince your professor. If you don't even convince yourself, most likely you will not be able to convince your professor you're on the right track. Do you follow me? Does that make sense? Yeah, every step you have to convince yourself you're doing the right thing and why you're doing the right thing. Okay. So by this time, we have a single quotient. If you are like me, you want to simplify everything to the simplest possible, you probably go one more step. What did I do? I have divided both sides by 2. By doing that, I make my quotient as simple as possible. I divide both sides by 2, I don't need to change the direction, right? I don't need to change the direction. Could I do more? Yes, I could, but I'm going to just stop here. And then you can see, then you can work the steps of similar to number 1. Okay, similar to number 1. I want you guys to follow these steps very closely. Of course, after this, we're going to take a break. Okay, we're going to take a break. But I'm going to ask you guys to do this all over again by yourself. Okay, the sign of x. What is the sign of x, right? It's just a one single number. That's easy. It changes sign as 0. Right? It changes sign as 0. Okay, so when x is negative, the sign of x is negative. X is less than 0 is negative. When x is 0 is 0. When x is positive, it's positive, right? It's very simple. Do you follow me? How about the sign of 3 minus x? Uh, 3 minus x. Once again, it changes sign as 3. Okay. When x is less than 3, what is the sign of 3 minus x? It's a positive, right? When it is 3, it's 0. When it is larger than 3, it's negative. Do you guys agree? From this example, you should also understand it's not always You know, you always start with negative and then you zero positive. Don't get into that autopilot, okay? This example is to serve that purpose. Sometimes you have positive on this side. Do you follow me? Changing sign is not always from negative to positive. It could be from positive to negative, yeah? Does everybody follow me? Okay. Last but not least, sine of what? X over 3 minus x. Number line. We have a 0 here. And we have a 3 here. Right? And sine. When we pick a number less than 0, we're doing a negative divided by positive. Negative divided by positive is what? It's negative. At 0, what happened at 0? When x is 0, denominator is 3 minus 0. The numerator is 0. So in this case, the quotient is 0. When x is between 0 and 3, we're dividing a positive by a positive. At 3, what happens? At 3, we're dividing by a positive number by a 0. Dividing by 0 is undefined, so I'm going to put a infinity there. Larger than 3, what happens? A positive divide by negative. Okay, so it's not always positive, negative, positive. It could be negative, positive, negative, right? So I want you guys to see the pattern could change. Don't allow yourself to get onto that autopilot. Okay, so now, what is the inequality we are solving? Right here. Okay, we want that quotient to be greater than 0 or equal to 0. So you're solving this one using, so you have to guarantee all of these steps are right, really. Otherwise, you're gonna be making big mistakes, right? So because this is the inequality we're solving for, you guarantee all the steps is right, and you want the quotient to be greater than 0 or equal to 0. And here we go, greater than or equal to 0. What do we get? So the solution will be what? The solution will be x must be greater than equal to 0, right? And it must be less than 3. It cannot be 3. So that's the solution to this question. Okay, we're going to take a break very briefly. Okay, I'm going to leave this on the screen for you guys to take notes. Maybe I'll make it a little smaller. Okay. And during the break time, and of course, I expect you guys to take a break. Take a break. After the class, you should try to do this yourself, okay? It doesn't look as trivial because when I graded my students' work in the past, when we were teaching in the classroom, this is the example I go over every semester. This is the example I go over every semester, and I quiz my student and I test my student. Guess what? I never get 100%. I never ever got 100%. I don't know why. Sometimes I test the quiz multiple times for the same class. A lot of students will stumble on these algebraic steps, which is really sad. Okay. So this would reflect that you need to work more on your algebra. You need to work on more on your algebra, okay? Which is a practice, really just a practice, right? If you think about Kobe on the basketball court, you just drill yourself. Instead of on the basketball, you are drilling in your on paper or pencil. Okay, I see a question here. I'll answer that question. How did a 2x over 3 minus x greater than 0 turn into x over 3 minus x equals 0? This is because I divide both sides. Divide by 2 on both sides. You don't have to. You don't have to. Only nerdy people like me would do that. If you don't do that, you work with 2x, which nothing will change. Do you follow me? Whether you have a 2x, 1x, it's 2 times x, the sign is still staying the same. Do you follow me? So if you don't do this dividing by 2, it's going to make no difference in your solution. Do you follow me? So whether you do 2x or 1x, it's not going to make any difference. So I'm going to put a parentheses there. You can work with this guy, with that guy. Did you get it? I divide both sides by 2. Okay. All right. So let's take a break and come back at 9:25. Okay. I will see you in a little bit. Get started again. All right, so this is a typical question. Okay, this is a typical question. And we have pointed out some of those most common mistakes. And the rest of these exercise in section basic 10, they're all similar. They're all similar. You just have to make that one single quotient. Okay, you make a 0, you make one quotient, and then you follow principle number 6. Are these the only way to do it? The answer is no. There are other ways. Okay, there are other ways. When we cover things like that, I really want you guys to master some of these basic methods with the basic principles behind it. Okay, and from that, you probably could create your own. Okay, so do you guys have any question about your particular methods, or you want me to give you some feedback on, a certain way you do it, right? And I just want to warn you, okay, you might encounter TAs, professors, or other fellow students who do the wrong way, and do not be swayed by it. Okay, if you understand the reason that why we do the way we did it, then you should stand to your ground. We should stand to our ground. Okay, because these reasons following mathematical principles. So this semester, you see, I told you that the major theme we have is function and principles. Function and principles. These principles are timeless. They're meant to exist for eternity, and they're correct to eternity about numbers. Okay, function from that definition is all we do. The different aspects of functions, that's what we do. Input, output. So when you look at all of these mathematics you deal with, they're all about this. Input, output. Of course, in calculus, you're going to learn about implicit function. But the idea is still the same. It's still the function concept. And the function concept will carry you directly into computer science programming. Okay, even if some of you are going to be, you're going to be a computer scientist, or you're going to be a software engineering, or anything you do, even you'll be in business, right? You will probably still learn some softwares and business applications of those applications. And the concept of function is omnipresent. Omnipresent. So that's why I focus so much on this concept of function, to see its various forms and various aspects. This is a function idea, is a big idea in mathematics. It's one of those big ideas that permeated through this entire subject. Okay. I'm certainly not a master of mathematics, right? I only learned a little field of, for my thesis to that, up to that point. But the function, the concept of function permeated throughout the field of mathematics and permeated throughout all the fields of application. You name it: biology, physics, chemistry, anything that's number related. When they eventually want to digitize, okay, they want to make their process, into program, into digital side, digitize their process, right? Digitize is the modern words, right? And even including the database, large data set, right? Big data. When they try to process it, they still cannot be very far away from that concept of function, because they're still trying to find patterns. Whenever you try to find patterns, you will fall in function, one way or the other. One way or the other. So this function concept is big. It's a big concept. Do we still know the definition, guys? A function is a rule that assigns each element in set A exactly one value, f of x, in set B. Such simple words, just one sentence. Yet, how powerful it is. Do you feel the power of that definition? I think by this time, you should feel that power of that definition. It includes so many things. So many things. Okay, so that was about all these connections, and maybe we will understand this better. So when you do each set of questions, always remember these mathematical principles we've been talking about. Okay, while you're working on enhancing your algebraic skills, and all of us must you must enhance your algebraic skills. Okay, I have emphasized that over and over again. But also, when you're doing that, reflect on the definition, reflect on the principles, because really these principles are being used this way, that way, so on and so forth. Okay, so shall we pick up a couple more questions, maybe one or two questions to work on basic 10? Or do you think you guys can handle the rest? I think you should be able to handle the rest, and they're just a little bit more complicated. How about each one of you choose 2 questions from basic 10? Okay. You choose 2 questions to work on. How much time I'm gonna give you? I'm gonna give you about 5-10 minutes. 5 minutes for each question. That should be reasonable. I think when someone's speaking, the Zoom should tell us who's speaking. Yeah, it should do that. How come I got messed up? I took Cortland for Mikhail earlier on, and I apologize that Cortland. If you want to share your work, if you want to share, okay, Cortland said number 6 from basic 10, number 6 from basic 10. You want me to work that? Sure, I can start working on that. We have making zero. You don't have to write these words, and I write it down just to prompt you about these key steps. And then we're gonna make quotient, make a quotient, one quotient. Okay, make zero, make quotient, and we have x over x plus 1 minus, here you have 3x times x plus 1, x plus 1. I'm going to insert one step. Okay. Of course, you can stop here, but I would not. I would just like to make my life a little bit easier. Okay, so I'm going to multiply both sides by -1. Okay, so I'm going to bring this one over here. And I'm going to factor out the negative sign. And this turn positive. Okay, and of course, I'm also factoring out the x. So 3x plus 2. Okay. And I'm going to multiply both sides by negative sign. If I multiply both sides by -1, then I will be having this. Okay, negative sign disappears, so this is greater than or equal to 0. So this is my one quotient with factors. Okay, the other technique that's very, very useful is factoring. Right? When did you guys learn about factoring? I remember learning about factoring in elementary algebra, right? And ever since then, there's a lot of factorings, right? There's a lot of factorings. Will factoring be needed in calculus? Absolutely. It's one of those basic skills. Then you say, why factoring? Why? If you go back to look at the principles, look at the principles. We have 6 principles. Number 6, principle number 6, you need a factoring. Principle number 5, you need a factoring. Okay? Principle number 1, you need a factoring. Anything times 1 stay the same. You need factoring. And the way we use principle number 6, anything at 0 stay the same, you also need factoring. Remember when we make the perfect square? It was a factoring, right? Yes? So that's why factoring is such a basic skill. Because why? You always need factoring. In calculus 1, you need factoring immediately. So now we have this quotient, we have factoring, we have 3 factors. So how do we view this? We basically view this as what? A times B divided by C. And we want that to be greater than or equal to 0. How many cases could there be, right? If you have a positive, 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 you get positive. If you have positive, negative, negative, you get positive, right? Negative, negative, positive again. So you have all these cases. Do you guys follow me? So what do we do? Sine of x. Okay, so we can start with sine of x. What's the sine of x? This is familiar to us, right? X changes sign as 0. Okay, so when x is less than 0, it's negative. When x is 0, it's neutral. When x is larger than 0, it's positive. So we have taken care of the first factor. Let's look at the next factor, 3x plus 2. What is the sign? When does sign is 3x minus 2, 3x plus 2 changes sign? When does that change sign?
Negative 2/3.
That's right, negative 2/3. Okay, so you're gonna have negative 2/3. Negative 2/3 is right here, right? Negative 2/3, and it changes sign. Okay, so when x is less than negative 2/3, is it positive or negative? Just plug in a number, right? Just plug in a number. Plug in, say, -1, and you're gonna have a negative. So negative. At negative 2/3, is a 0, right? Beyond the negative 2/3, positive. You follow me? Next one, x plus 1. Where does x plus 1 change its sign?
-1.
That's right. So instead of, we just have a little bit more to, we just have to deal with more number lines, right? So at a -1, let's look at the relative position, right? Negative 2/3. Let me move this, just scoot over a little bit, right? So I'm going to make this -1. Okay. We want these numbers to line up for our convenience. Okay. Don't mess up. Don't mess up. Because if you messed up, you messed up big. It will lose the visual, it lose the purpose of the visual effect. Okay. So don't try to mess up. So when I'm making these 3 number lines, so this is 0, this is a negative 2/3, and this is a -1. They should be in the correct relative position. Otherwise, it's gonna be a mess. Do you follow me? If you don't have this, you're gonna make a mess. You may rather not to make it. Okay, so this is what I'm trying to do. Did you guys follow me? And for x less than -1, it's going to be a negative. At -1, it's 0, right? After -1 is positive. Okay, you can make these shorter, really. You know, we don't really need all of these things, right? You can make it shorter. Just make it, you know, so you see it as you see it as a comfortable. And finally, we want to look at the sign of this quotient. Sign of this quotient. Okay, number line. On this number line, we have a -1. On this number line, we have negative 2/3. And on this number line, we have what? We have 0, right? We have 0. Finally, we just have more intervals, really, right? We just have more intervals. Let's see. Okay, I'm going to make it a little smaller so we can see all the number lines. This is just a little bit too big, 125%. Okay. So we have all the factors, right? So when x is less than -1, so we're doing negative, multiply negative, divide by negative. So 3 negative signs in the quotient. So what would it be? The quotient would be what? You follow me?
Negative.
Does everybody follow me? When we choose a number less than -1 on this side, we choose a number from here. And then, you follow me?
It would be negative, right?
That's right, because in your quotient, there are 3 negative signs, right? Yes? So these will be negative. At a -1, what happened at a -1? The denominator will be 0, so that's undefined. Follow me? Between -1 and the negative 2/3, what happens? You have 2 negative signs in the quotient, right?
Would it be positive?
That would be positive. Okay, at negative 2/3, what happens?
0.
It's a 0. Very good. Between negative 2/3 to 0, what happens? Look at that.
Would it be
You
negative?
have one negative sign in the quotient, so that will make it what?
Negative.
Negative. At 0, what happens?
It's 0.
It's a 0. Beyond 0, what happens?
Positive.
3 positive sign in the quotient, therefore they're positive. It's just a little bit more complicated, right? It's just a little bit, it's just one more interval. Okay. So finally, what is the answer to the solution? But then you have to look at what is the inequality? The inequality is that we want that quotient to be positive or 0, right? So where do we get the quotient positive or 0? Where do we get that? Hmm?
Between -1 and -2/3, and then from 0 to infinity.
That's right. Solution to this inequality would be, right, over here, right? So then you're gonna write it down, the interval, and they cannot include a -1. -1 makes 0 denominator, right? So you're gonna have a -1 less than x less than -2/3. Or x is larger than or equal to 0. And that's the solution. By doing this, every number on the number line is considered. Do you follow me? So it's not possible for you to miss any solution. So this systematic way of treating these inequalities guarantees you don't miss any solution, because our task is to find all the possible solutions. Do you follow me? Okay. So far, so good? Well, we have 8 minutes left. We can still rush in one more question. What would that question you would like me to work for you? Huh? Anybody?
Number 8 seems pretty difficult.
Huh?
Number 8 seems pretty difficult.
Number 8, if you feel it's difficult, that means you need algebraic practice, right? You see, we have the principle, we have all these ideas, everything's been clear. And the rest you need to do is practice with the algebra. You need to enhance your algebraic skills. Okay, so I'm gonna do number 8. Okay, so make it just a little bit larger. The first step is still what? Making 0 and then making 1 quotient. Okay. A lot of our students, they will tell us, I understand, but I can't do it. They didn't say that I cannot do it, but it's just I understand everything, but you look at their work, it seems that they do have difficulties. And the difficulties often is in the algebraic manipulation. And that just tells us it's a lack of exercise. Lack of exercise, period. No other reason. No other reason. And these two will work with you interchangeably, because if you lack algebraic skills, then you have a lack of understanding of the principles. If the lack of understanding of principles, you have a lack reflected. So these two, sometimes you don't know which one is chicken, which one is egg. Okay, it's a kind of chicken egg problem. So my solution to that is you practice as many as you can. Okay, this is the reason for this handout I give you. Okay, the number of pages keep increasing over semester, because every semester I modify it. Every semester I modify it. Okay, but the bad news is the number of pages keep increasing. Okay, because I wish to give you something that is inexpensive, which costs you nothing, but yet you can practice with it with just following simple principles. Do you follow me? I don't believe you pay $200 to get a textbook is going to get you learn. That's not going to, it's not going to help. Maybe it may help you a little bit if you read it. Okay. And because all that $200 to a textbook, they probably talk about the same thing. Right? I'd rather have a $10 textbook and put everything together in a logical way. I think that would be even better. That would be better. Okay, it's not the price of the text, it's how much time we practice. All right, so without further ado, okay, let's see if we can finish. If we cannot finish, and we hope we'll get to the point that you will be able to finish, right? So make 0, right? And make a single quotient. And over here, we're going to have common denominators greater than or equals to 0. Okay, so over here and over here, we're going to have to make the common denominators. The common denominator, obviously, it's x plus 3 multiply x minus 2. So I will do a x minus 2 here. Anything times 1 stay the same. I'm using principle number 1. And this is going to be x plus 3, x plus 3. I got the same denominator, which is x plus 3 times x minus 2. The numerator, I will have x minus 2 times x plus 2 minus x plus 3 times x minus 1 greater than or equal to 0. So all of these, if this is true, then this. If this is true, then this, right? So we're going through that line with if statement all along the way. The denominator is such, and the numerator, and the FOIL this, you get x squared minus 4. And I'm going to make it just larger for you guys to see if that helps, right? Minus, and this product, and I'm going to do it slowly, FOIL plus 2x minus 3 greater than or equal to 0. And next, I'm going to open up the parentheses, distribute the negative sign into the parentheses. So there's everything going to change sign. Plus. Right? Just tell me everything we have done so far. Is there anything you have not learned?
No.
You have learned everything.
Yeah, it's just a matter of putting it all together.
Exactly. Absolutely. You're absolutely correct. Right? And now we combine like terms, and x squared, negative x squared, take away the x squared here. And this negative 2x and negative 4 and 3, that's making negative 1. And the 3 is gone. So I have a negative 2x minus 1 greater than or equals to 0. If I want to factor out the negative sign, I can. Okay, so I factor this out. You know what I'm going to do next, right? Factor this out. Okay, and I'm going to divide both sides by -1. Divide by -1 and switch direction of inequality sign. So I believe this is the simplest I can get. Do you agree? A lot of our students will not be able to handle these operations, just to tell you the truth. But you absolutely need to be able to handle this. Okay, these are called basic skills. These are called basic skills. And the rest is simple, right? You start working with the sine of, I think we can finish this, okay? Sine of x plus 3, right? And sine of what? 2x plus 1, right? Sine of x minus 2. You just work the, are you guys working with me? If I were you, I would, after class, I would do this all over again and then again, to enhance my algebraic skills. I promise you, your algebraic skill will be enhanced in less times than the number of shots Kobe had to make with his basketball. I promise you. Okay, if Kobe made a 10,000 or 1 trillion, you don't need to do that many times with your algebraic skill. If you don't believe me, you can give it a try. Okay, find out how many Kobe made that shot, how many times he practiced before he made it. Okay, I think that would be an interesting comparison, isn't it? Okay, so here's a -3. Right? So that's going to be negative. That's going to be 0. And that's going to be positive. Right? And for the sine of 2x plus 1, and where does it change sign?
-1/2.
-1/2. Perfect. -1/2. Okay. Boom. Okay. And changing sign, in terms of changing sign, when less than -1/2 is a negative, equals to -1/2, that's 0. And larger than -1/2 is a positive. Okay, you guys got to do this with me to enjoy the ride. Okay. And then last but not least, where does x minus 2 change sign?
+2.
+2. Perfect. Perfect answer. Okay. And for x less than -2, less than +2, it's a negative. At here is 0, and afterwards is a positive. Okay, so now I'm going to make this a little smaller because we're going to see the quotient. So the sine of this quotient right? The number line, and I'm going to line up. Okay, I'm going to make it 120% for the fonts. Okay, so we can see everything. Okay, so we can see everything. Our time is up. If you have to go, you can go. Okay, so let's line them up, right? Line them up. I'm sorry, I think there's some issues here. There's some lining up issues because I changed the fonts, okay? So can you guys finish the rest? You will need to be able to do this in your calculus class, except that at that time, your teacher probably teach you the way in the table. Okay, I found this method is more visual than the table, but if you understand this method, you should not have any trouble understanding the table. Okay, there's so many there's different ways of doing it, but it's all using principle number 6, really. No matter what you do table, you do this way, that way. There are at least 3, 4, 5 ways I can think of to do this, right? But they are under the guideline of, principle number 6. Okay, so these, so what do we get? Right, so here I'm going to put a -3, right? And over here, I'm going to put a -0.5. And over here, I'm going to put a +2. So what are the sign do we have?
Negative.
3 negative sign in the quotient. So that's going to make negative. At -3, what happened at -3? It's undefined. Between -3 and -0.5, you have 2 negative sign, 1 positive sign. So that's going to be positive. At -0.5, it's a 0. Between -0.5 to 2, that's going to be 1 negative sign, 2 positive signs. So it's going to be negative. At 2 is 0. No, undefined, sorry. At 2 is undefined. Beyond 2, positive. Yeah? Does everybody follow me? Now, finally. Okay, solution. What is the solution to this inequality? We want the quotient to be less than or equal to 0, right? So what do we get? Where do we get the negative, right? X less than -3. Okay, or between -0.5. Does it include a -0.5? Yeah, it makes 0, right? Less than 2. That's a solution. So you know what you need. Practice. And practice, yes, you have lots of practice there waiting for you. Okay. And I'm very proud of you guys have made it this far. This is the end of week 7. Okay, next week is week 8, and in the middle of week 8, and the midterm exam will be given to you, and you're allowed enough time to do it. And throughout the spring break, okay, because after week 8, we're gonna have a spring break. And so it's time for us to look back, okay, get some more practice and do some more summaries and so on and so forth. And don't forget, I will still be available during the spring break, even though it's a break, but I'll make myself available. If you have any question at all, please don't hesitate to reach out to me. Okay. I think that's all for today. I'm sorry, 5 minutes passed, but keep on with your good work. Okay. And I really enjoy the interactions we had in class. I really, really enjoyed that. And I appreciate that. That really enhanced my lecture. At least it makes me feel I can help you in ways that I, more effectively. Okay, so without further ado, I will see you guys on Monday, if not sooner, and I'm going to jump in my office hours. And I'll see you guys Monday, if not sooner. Thank you very much.
Thank you.
Very good job. Very good job.